watch it too. All right, this is going to show you how to graph a rational function by hand. There is a worksheet at the top of Chapter 5 under this thing right here, graphing rational function by hand, that gives you all the steps and tells you what to do. But I'm going to go through this particular problem with you right now. There's 6 steps involved with this. Okay, and this is the function that they give you in the book, number 47. It's 3 over x squared minus 4. So step number 1 is me find the domain. All right. So if I find the domain, how do you find the domain of a rational function? What do you do? So the denominator equals to 0, right? So I'm going to set x squared minus 4 equal to 0. So that means that x squared is going to equal 4. So that means that x is equal to what? Plus or minus 2, right? So the domain then is all real numbers x such that x does not equal plus or minus 2. Does that sound good to you guys for the first part? That's step 1. Find the domain. Okay. Step 2. Find the x and the y-intercepts. So to find the x-intercepts, anybody remember what we did from yesterday? What was the thing from yesterday? Set what to 0 to find the x-intercepts? Set the numerator to 0, right? So does 3 ever equal 0? No, so that means there is no x-intercept. Okay. How do I find the y-intercept? What do I do? No. I evaluate r of 0. Evaluate r of 0. So plug in a 0 for x. That's going to be 3 over 0 squared minus 4, which is negative 3/4. So I now know there's an x-intercept, or sorry, a y-intercept at negative 3/4. So y-intercept is to be negative 3/4. I'm trying to fit this all on one screen. That's why I'm crunching it together. Okay, vertical asymptotes. What we learned yesterday about vertical asymptotes and rational functions. Is there a correlation between something? Yes, the domain, exactly. So there'll be 1 at x equals 2, and there'll be 1 at x equals negative 2. Sound good to you guys? Yep. Same thing as the domain. Vertical asymptotes and domains are related with rational functions. Okay? Find horizontal or oblique. Now, is this rational function a proper rational function? Who says yes? Who says no? Who says I don't know? All right. How do you tell if a rational function is proper again? If the degree on top is smaller than the degree on the bottom. So what is the degree of the numerator of 3? 0. The degree is 0, right? What's the degree of the denominator? 2. So 0 is less than 2. So yes, this is proper. You guys agree with that? This is a proper. So that implies that y equals 0 is the horizontal asymptote. Okay? That's what that implies. If your function's proper, then the horizontal asymptote is y equals 0. And proper means the degree on the top is smaller than degree on the bottom. That means no oblique asymptotes, since you cannot have both horizontal and oblique in the same function. Okay? Sound good to you guys? All right, good. So we take care of that. Step 4. So far we've done step 1, find the domain. Step 2, find x and y-intercepts. Step 3, find the vertical asymptote. Step 4, figure out any horizontal or oblique. And then step 5 is we're going to start putting all this information onto the graph. So what I do first is I just draw the x-axis. And I put in some key points on the x-axis. Now I know that my domain at negative 2, so if I call this negative 2, I'm going to vertical asymptote at negative 2. I also know positive 2, so I'm going to call this positive 2. All right? I know I'm going to have a vertical asymptote at positive 2. Okay? Do I have any x-intercepts? No, there's no x-intercepts, so it's not going to cross anyway. Do I have a y-intercept? I have a y-intercept at negative 3/4. So that means that if I call this 0, this is about 0, right? So here's, I know down here at negative 3/4, I'm going to have I'm going to intercept. Okay? Now this leaves 4 regions to talk about. I have this region over here, which I'll call region number 1. It's this one that's to the left of negative 2. So this region is region 1. This region is region 2. In between negative 2 and the intercept. This is region 3. And then finally this is region 4. You guys understand so far? Yeah? Okay, so what I need to do is I need to take in that region to figure out what's going on. Oh, by the way, I also know horizontal axis is horizontal asymptote, right? So what I need you to do is take test points in this region, okay? So what's a test point in region 1 that I could see? Because my graph is either above the x-axis and going up like that, or it's below and going down like that, and all I need to do is take a test point. So yeah, we'll say -4 is a good test point over here. How about in this region? -1. How about in this region? 1. Great. And how about this region? 4. Good. Now what I'm going to do is, you can use your calculators, but I'm going to write this out. And so I'm going to say, this. F of x is our function, and our function is 3 divided by x squared minus 4. Yeah, I'll fix that. Is that 1 though? Okay, so let's do that. Good. Now I'm going to ask my function here, what is f of -4? And we'll ask Fluidmath to figure out what it is. And is my answer positive or negative? Positive, right? So that means it's above the x-axis. What about f of -1? What's that going to be? Positive or negative? That's going to be negative, so that's below the x-axis, okay? How about in region 3? I want to figure out what's of 1. And it'll be positive, right? Or no, -1. So I have -1. And then finally, what's f of 4? And that's going to be, when it figures it out, funky. That's going to be positive, okay? So now I know in my region, I know all these things, what's going on, so I can go back up here, okay, and I can plug into the graph. In region 1 was positive. My graph is looking something like this. Region 2, my graph is up like this, and then it's crossing that x-axis. In region 3, it's going down like that, and in region 4, it was positive, so it's looking like this right here. So that's the sketch of my graph. You guys understand that part so far? Yeah. Then at the very end, okay, you can graph this on your calculator and see. So let's see if I can do it from here. Mode. So our graph looks exactly like the one that we like that, and worse.